Perfect. All right.
So you get a hold of John. Was he planning to attend?
No, John isn't John is in Sajib, so he said he can make this.
Okay.
Did you know that Kevin's?
Kevin is also excited. So he met Linda Ford, and she seemed pretty enthusiastic about the proposal. So I thought all that is good. She didn't attend his lightning talk, but
Good.
we're hopeful.
Okay. Are we synced again? I was wondering if we could maybe just start with like quick introductions from everybody, because I'm guessing not everyone knows everyone here. And so just like name and what you're working on and where you're at would be probably good. I can start. I'm Lindsay. I am currently a postdoc at UC Berkeley. So I moved down here from Vancouver at the beginning of the year, basically. And so I'm working on Jupyter in the geosciences, and specifically working on like integrations of SimPEG with Jupyter. Why don't the CSM folks say hello?
Hi, I'm Andrea Dar. I'm a PhD student with Dr. Yago Lee, and I'm working on characterizing anisotropic.
We can hardly you're half off the screen, Andrea.
Oh, I'm half off the screen.
There we go. Okay.
Hi. So I'm working on characterizing anisotropic parameters through joint inversion of control source electromagnetics and MT. So I was looking at possibly using SimPEG to do those inversions.
That's Dr. Lee. I'm Andy McAlilly. I'm a PhD student. I'm one of Yago's students, and I've got a few projects. The one that probably brings me here is a time-lapse controlled source EM project. And then we've got Joe here as well, but he's kind of wandering in and out, so maybe he'll introduce himself in a couple minutes.
Yeah, Joe's unknown. No one knows.
No, nobody knows who Joe is.
All right. Sagi, do you want to say hello? You're muted.
Hi, I'm Sagi. I'm at Stanford as a postdoc. I'm mostly working on airborne EM in these days, particularly for groundwater problems in California. Yeah, nice to meet you guys.
All right, UBC.
Okay, well, we can go around the table here.
Nice.
Whoa.
Stereoscopy. I'm Don. I mostly do potential fields and regularization.
I'm Wahid. I'm actually active in gravity and magnetic modeling. I'm here for my sabbatical period and wants to model my data by SimPEG in UBC for, say, about 1 year maximum. Thank you.
And fresh from the Whistler ski hills, we have
Sarah. Hi, I'm also visiting here for a sabbatical stay, and I'm working in the hydrogeophysics community, more on soil-plant interaction problems with geophysical techniques.
when she's not skiing.
When I'm not skiing.
Hi, I'm Devin Cowan. I work on various things, but right now it's mostly documentation and software development for various projects at UBC GIF Group.
Mike, I'm trying to finish up my PhD here, and I work mostly with DC and electromagnetic methods in mine workings. So just how to use them in kind of an underground environment to image things around your tunnel.
Hi, my name is Thibaut. I'm a PhD student here with Doug, and I'm focusing on geological and petrophysical constraints for inversion and joint inversion.
Perfect. Let's see.
And Professor Oldenburg.
Getting dizzy.
Yeah, oh yeah, so I'm Professor Oldenburg, and everything I ever learned about inversion, I learned from one of my graduate students who went on to be a very famous professor in the United States at some Colorado School of Mines or something. Anyway.
Anyway, I didn't realize there are other members on the meeting, so I should actually introduce myself properly. I just thought everyone there. Globally, I did my PhD undergrad some years ago, and I got kicked out of Canada, came down here to Colorado School of Mines. So my interest is in inversion, primarily potential field, dabbling into EM. And that's actually what brought us to this meeting today. So thanks, everyone.
Just so you know, UBC, I just muted you. We were getting a bit of feedback. So Doug, if you do want to speak, please just unmute yourself. It doesn't actually look like I can unmute you. Sorry. So Dom or Thibaut can jump in and do that. Yeah, with this many people, sometimes you get these feedback loops. So Thibaut, are you okay helping Doug with mute versus unmute? Are we UBC good? You're still muted. Okay. So just unmute if you want to jump in. So what I was thinking we could do is first just do sort of quick updates on things that we want to make sure the whole group is aware of, or interesting things you've been working on. And then from there, we can move on and go more into some discussion on how do we support the SimPEG, because there are some challenges right now, like documentation is sort of not in a place to sort of dive in without being in touch with them. So yeah, do some strategizing about that. It looks like we also have Kaylin joining from SJ. Hey, Kaylin.
Hi, Kaylin.
Hey, can you hear?
I think everybody's waving, but I can't hear anything.
Okay, that's
so.
That's a problem on their end. To like email them. What's or
oh, there we go.
Sorry, one sec.
Hmm.
Can you hear us?
Well, I mean, you might let's take an example.
Okay, so yeah, Dom, if you don't mind just like going back and forth, and we can try and get him up and running, but not totally stall. Okay, so one quick update from my end. I was at the Jupiter team meeting last week, so that sort of, I didn't really get much done on the SimPEG side of things. But we've been pushing a little bit more on the discretized documentation. That's getting cool. And then Dom, it looks like you have an update with John. UBC, you're muted.
Okay. Can you hear me?
Yes.
Yeah, right on.
Maybe also turn the camera.
Yeah, they can see me here, I guess. So last week, I was telling you guys that John and I at DIA started working on the magnetic radiometry kernel function. So we're really close to be done the testing on this, but I didn't want to have to wait. So can you see my screen all? Yeah, it's all good. Lindsay?
Mm-hmm.
Yeah, screen is good. So we're starting to thinking in terms of like being able to have multiple components on the magnetic survey. So instead of only having TMI as usual, so we can have also the gradients on the object. And so I just coded the first implementation of it. So that works really well. And then right away, because everything is already hooked up, we were able to do the first inversions. So we'll be able to do MVI inversions on mag gradiometry. So yeah, everything works great. Here's the nice collaboration. This is a $100,000 picture right there. This is the VTK-I viewer of Bain using Joe's tree mesh.
That's really
And then
cool.
MVI code with the gradiometry from John and I. So there we go. Collaboration. And then I'm just going to show you the comparison. This is TMI only, the bottom one, versus if using DBDZ plus TMI at the same time, right? So just getting better edge. Looks like we're going to get better edges, better constraints on the vectors if we use multiple components. So I think it's nice progress. We'll start a pull request next week on this, so we can bring it in.
So what was the true model there?
It's the usual. The usual.
45 degrees.
No, because right now we have issues with magnetization not vertical. We're still working on the kernel, but it's just vertical block. Yeah. On an upstream mesh. That's it. That's my 60-second pitch.
Very nice. Thanks, John. This is exciting to see. Does anybody else have quick things that they would like to bring up to the group?
I think it's our end.
Let's see if. Okay. All right. Well, then let's start the conversation a bit about what we can be doing to support CSM. So what challenges have you run into so far? And then maybe we can try and come up with some strategies for like a productive back and forth. So as you run into challenges, we can try and help fix them, but also make sure that that stuff is documented so that in the future, other people can learn from that. So do you maybe want to just give a bit of an overview? I know, Andrea, you mentioned, so anisotropy, MT. Yeah. Do you want to just give us like a bit of an overview of what you're thinking and also what you've perhaps tried to do with SimPEG or what you would like to try and do?
Yeah, of course. So I'm trying to use control source electromagnetics and MT. So I would like to characterize anisotropy parameters. So preferably, I would like to have a full 3x3 anisotropy tensor in order to do this. However, as far as I'm aware, SimPEG only has a scalar anisotropy input at this point, or sorry, scalar conductivity.
It's actually, it does support full anisotropy. It just
it does. Okay.
Not documented anywhere. So yes.
Okay,
I guess that's precisely Doug's point Sunday. That so Andrea looked and
yeah,
couldn't find any. So Doug mentions that there are a lot of stuff that's behind the scenes that's not documented. So this really.
Okay, yeah.
Especially research applications. Like if you're trying to do sort of a straightforward inversion, we have a fair number of examples for that. But as soon as you sort of start going into something that is a bit out of the ordinary, a lot of that stuff is not documented.
Okay.
Okay, so that's good to know. Anisotropy.
Mm-hmm. It is that for both the FDE
and are you looking at starting with forward modeling?
Yes.
For now?
Yeah.
Okay.
Eventually, the end goal is for a joint inversion with both CSEM and MT.
And when you say CSEM, what kind of source are you?
Grounded is this point.
The grounded source? Okay. And frequency domain or time domain?
What is your data in?
Frequency domain.
Frequency domain. Cool.
And if I can just jump in, one comment is one of the paths that we're thinking now is actually going through is the Fuzz-Simmons clustering-based inversion for the anisotropy, and that goes parallel with two methods that actually gives complementary information about anisotropy. So that's the general direction Andrea is going.
Cool. And so in this case, would you be looking to use SimPEG just as the forward modeling machinery, or do you want to actually, and like you have your own inversion, or actually do a bit of both?
I was just at right now. I was just at the forward modeling stage, but I would be fine with either. Yeah.
Okay. Well, I mean, and that's something that like is a bridge that we can cross when it makes sense.
Mm-hmm.
Okay. And so if you're doing full 3D, Doug mentioned that you were looking at EM-PyMod as well?
Yes, I was, which only has horizontal and vertical. So it doesn't have the full capabilities that SimPEG has, now that I know that.
Yeah. And it's a 1D code, but in it might be a good starting point as well. And we're actually, like, so Dieter, who's the main developer there, he's in the SimPEG Slack.
Okay.
And we've worked with him, and we have a first pass of an inversion of EM-PyMod working. So if you want to play around with like 1D inversions with that code, that's an option. But right now that code is like sort of, it's in development. It's not actually well documented. So that's something that we can be in touch on, if that makes sense.
Okay.
Lindsay, you mentioned earlier that the full anisotropic capability is in SimPEG. Would that be for 1D or including 3D?
In the 3D. So full anisotropic do in the 1D case, because it starts becoming a 3D problem. But yeah, we do have full anisotropy for 3D.
Okay, thanks.
Now the inversion would need some careful thought. We don't have, so the inversion right now is only reasonably well hooked up for diagonal anisotropy, not for the full tensor. So if you just have sigma x, sigma y, sigma z. But if that's something that's of interest, it's not like that much of a stretch. We would just need to give some thought to the implementation.
So that's actually that sounds great, because the inverting for the full anisotropy and also exploring the possibility of using the Fuzz-Simmons clustering, which Joe has worked on in PCFT case. All of those really kind of will be part of what Andrea's research is. So I just want to make it clear that there's an expectation that all the burdens on the entire SimPEG team to get all those things done. At this point, as long as Andrea has get the full modeling capability up, then she can proceed with the research. Eventually, of course, as we've been discussing, the work that's done will, that aspect will be able to kind of brought back into SimPEG.
That's great. Sagi, did you have a comment? I saw you unmuted there. No, you're good. Okay. Doug, was there anything or the UBC group you wanted to mention right now? You're muted. No?
Actually, I got one question for Andrea. So do you have a geologic example where you really need to consider that this full anisotropic problem? Yeah, just kind of curious, what's the motivation here to consider the anisotropy?
Well, the end goal is actually to see what anisotropic properties we can actually recover. And that's why I want to do the joint inversion. with the MT and CSEM to see what I can recover using those methods and have an evaluation of those parameters and how well we can recover them using that type of joint inversion. So, but the end purpose will be for geologic interpretation.
Yeah, other comment I want to make is that it's pretty rare to have the principal directions of the anisotropic physical property aligned with using coordinate. In very rare occasions you might see that, but as soon as you have a couple of different geologic units that their principal directions are not aligned, then in the same coordinate system, you might end up with have to deal with the full anisotropic tensor. So that's just kind of thinking in general application of this scenario.
Yeah, so following on that a little bit, what sort of scale of problems are you interested in? I mean, are these fairly small local problems, like mining types of problems, or are you large scale tectonic problems?
Right now it's mining scale, roughly.
And eventually your interest is more.
Yes.
Eventually what?
In hydrology applications to hydrology. Eventual interest.
And do you have like a specific area or a specific data set or question, kind of following on what Sagi has in mind that kind of helps drive how the research is going to go?
Yes, I'm using a data set that Andy has eventually. So.
And what is that? Is that a hydrology data set?
It is not.
No, the data that I've collected is over an oil field for CO2 monitoring. So it's a time-lapse data set. There's controlled source EM and magnetotellurics. But that's it's monitoring CO2 injected into a reservoir at about 1,400 meters depth, and the survey scale is on the order of 5 kilometers by 5 kilometers or so.
And what is the motivation for thinking that anisotropy is going to be important here?
In that setting, the reservoir is overlain by a lot of shale, which is going to have at least vertical and horizontal isotropy. And then in addition, that shale isn't necessarily, perfectly layered. It's not a perfect 1D model either. We're kind of at the edge of an anticline. So I would say that my project is kind of a jumping off point for Andrea, that the specifics of that, of my data set aren't the only motivation for her, but we have the data and it's a good opportunity for her to take advantage of it and then kind of move into the things that she is really interested in.
Okay.
Andrea's interest is not necessarily, so she has general interest in getting to the anisotropic conductivity. She's not necessarily motivated at the moment by specific project.
Okay.
So in a sense, this is one of those some of the UBC projects in obviously this is problem that Andrea's interest in the method, and eventually application area could be several different directions. For the work that Andy and I and we're working on, for the reservoir, oil and gas reservoir, the porosity data indicates that permeability data indicates the ratio, anisotropic ratio in the permeability can be up to 30:1. That's huge. Right? So in that case, you are going to see electrical anisotropy. So things like that. And other part that I'm very interested in the present fracture zones that will have the strong anisotropic probability, but also associated with that the electrical conductivity or anisotropic electric conductivity. So eventually the interest is not necessarily the anisotropic and electric conductivity, but by that, what can we get to in terms of the hydraulic parameters?
Okay, understood. So I again, just to kind of close the loop, thinking about a forward modeling in situations like this, I think is entirely the place to concentrate one's efforts, just to see if you can't figure out how to forward model something of the scale that you're interested in, and set up your transmitters, look at what the data are, and just get some sense about what that relationship is. So I think that's the perfect place to start.
And what is your familiarity like with Python and Jupyter? Have you worked with Python or Jupyter before, or coming more from MATLAB?
I have worked in Python and Jupyter Notebook before. I'm not extremely skilled in it, but I can use it to. I can use it proficiently, I think.
Yeah.
Yeah, proficiently. Yeah.
He always modest.
So. Okay, yeah, that's totally fine. Just kind of want to get a sense of like if we send you a Jupyter notebook, like that's a good starting point. Okay, yeah. One of the things, well, I guess there's a couple things that we can try and think about for starting points, and then also for perhaps how this like feeds back into the SimPEG ecosystem for us helping onboard other researchers. Because that's right now, I think one of the things that we struggle with is like, we're all doing our own research and like hold most of the code base in our heads, which is not useful when you would like to use it, because it's not documented. Sketch of just a simple canonical model that you want to start with, like 1D or maybe a little bit of structure in there, 3D, that's fine, but 1D is probably good.
Lindsay, you're breaking up. I think
just to get you up and running and sort of like the way SimPEG is designed. Sorry, you like froze there for a minute, but I'm assuming you heard. Did that come through?
No, you broke up quite a bit.
I think the gist was 1D example is a good place to start, just to get a sense of how SimPEG works in general. Yeah.
Sorry, can you say that again?
Yeah.
The 1D, and then you sort of cut out.
Yeah. You were cutting out while you were talking, but it sounded like you were saying a 1D example is a good place to start, and that would be an opportunity just to get a sense of how SimPEG works. Right?
Yeah. Mm-hmm. Yeah, so if you can send us a sketch, then we can send a notebook, and we can set up the simulation in 3D so that you can adjust the model as you like. But something simple to start with, and then actually that would be nice to get a comparison with something like EM-PyMod.
Okay.
So would that be for the just control source, or will there be a possibility of having the MT as well? So that's the one.
We can do that for MT as well.
Okay.
I would suggest we pick just one to start with and get familiar with the API, and just like we can sort of learn a bunch of things with one example and then move to the other. So whichever you prefer to start with, we can. Yeah.
Since Andrea has already been working with EM-PyMod, can we also run EM-PyMod through basically a SimPEG interface and just have a different familiarity with how to run the same code, and then also use that as maybe a stepping stone to going to like more of a 3D model with SimPEG.
Yeah, that's totally reasonable, and we sort of have a SimPEG like layer on EMPyMod. It's not actually embedded in the SimPEG code yet, but we can hook that up and send you a notebook that uses that.
Yeah, so then she'd have at least be kind of in an ecosystem that's with a SimPEG framework, even though underneath there's a code that you've actually used in script form and through another variation. But I think that might be a valuable transition.
Yeah, agreed. One of the things that would be helpful to do along the way, and you can do this however you're comfortable, but one of the things that I've seen when people are getting onboarded with a new code is them just sort of keeping a log of like their thought process and what challenges they run into along the way. So if you run a command and you get a strange error that confuses you, just like keeping track of those things is really valuable information for us and to help you as well. So if there's a space, like you can either do it in like a GitHub issue, or if you want to just keep a running Google Doc or something like that, that we can share back and forth. It's helpful because often like it's not as straightforward as debugging a simple function because there are so many layers to SimPEG. Sometimes there are non-intuitive things that happen. And so we sort of know how you're thinking about the problem. We can try and help diagnose that a little more quickly.
That's a good suggestion.
And are you comfortable with like Git and GitHub? Comfortable in like the sense of, have you cloned a repo and things like that before, or is that a new concept?
I have not cloned a repo or anything like that before.
Okay.
I've downloaded things off of GitHub, but that is as far as I've gone.
Okay. Because one of the things that might be useful, and we can give that a try and see if it works for you, and if not, that's fine. But we have a SimPEG research organization where we just sort of have notebooks that are like research projects. So I put all my notebooks from my thesis in this organization. So we can start a repository of notebooks or scripts or things like that, that way we can share things back and forth, and it helps us keep track of issues and things like that.
Okay.
So if you're in Slack, we can spend some time, maybe not with the whole group, but I'm happy to jump on a call with you and we can like set that up and get that up and running.
All right. Yeah, I would appreciate that. I'm not on the Slack SimPEG group yet, but I can join. I have Slack.
Okay, excellent. And I think, Andy, you are, right? So you know.
Yeah. Yeah, Joe and I both are. Yeah.
I'm on there as well.
Mm-hmm. Yeah, we can help Andrea get set up there.
Excellent. Cool. Andy, while we're on the call, do you have questions or things like with SimPEG that we could be supporting you with right now, or is it sort of just more keeping a pulse on what's going on in the project, or?
Yeah, I guess keeping a pulse is kind of where I'm at right now. Yeah.
Fair enough. Fair enough. Cool. Okay. And Joe, you were not here earlier. Do you want to say? I think you probably know most of the group, but there's a few new people at UBC that might not know you. Are you just in the corner?
Yeah. I think Andy, you probably hear me on Andy's, right?
Yeah.
I'll mute myself, even though it'll be coming out of his sound. My name's Joe Capriati. I'm mostly hoping to finish up my PhD soon, so I've just been doing a lot of little things. A lot of the tree mesh stuff I had rewritten for the discretized package to get it a little bit faster than it was before. Other than that, most of my interests are just kind of general inversion and also fluid flow inversions. And yeah. Any other questions? I don't know.
I just got one comment to the grounded source. I think we have a line current source like that can actually emulate the grounded source in a tensor mesh, but what we don't have, that's the same function for the octree code. So it'll be kind of helpful to get some help from Joe, because I think we haven't really used that octree mesh for the grounded source. So it'll be a good test case. Anyway, Andrea need that. So I mean, like it'll be a good feedback loop. So like everybody can benefit from that.
Soggy, would you be willing to start an issue on the SimPEG repo on that? Or we might already have one, but
yeah, I'll make an issue.
Do you know what that would require?
I think it's mostly like a searching function, like where the nodes in a cell, and yeah, mostly like how like the searching part is organized. So it's like a numerical integration code that's required. I mean, most of the basics are done in tensor, so I mean that's basically the same. But yeah, we just need a couple of functions for octree.
I think there is some code in there already that kind of searches for boundaries if that's what you need.
Yeah, something like that. I need to take a look, but yeah. Yeah, I can ask the details later.
Yeah.
Joe, I have a question too for you.
Sure.
So you pushed earlier this month a couple of updates from me, right, on the refined tree branch.
Yes.
Does it only live there? Like, are you creating a PR, or you want to bring this in at the same time?
I might just bring it in at the same time because I feel like it kind of bug fixes what you were having issues with that pull request with that branch anyway.
Yeah, sounds good to me. Sounds good. I'll start with PR then. I wasn't sure if I was waiting for you or.
Yeah. Oh, yeah, no, go ahead.
Yeah.
I'll add my comments onto yours.
Then here, Lindsay, I was just wondering, there's a few things in addition we could potentially talk about with the CSM group in particular, maybe looking at gravity terrain corrections and seeing if that's a point of connection here. But Kaylin is here from SJB, and a lot of the conversation that we just had carries over like virtually to him because they're just starting up with SimPEG. They're very interested in electromagnetics, large-scale loops, and yeah, the whole business of trying to get involved with SimPEG and even do the forward modeling is currently very much of interest. So maybe we just turn it over to Kaylin and he could comment about what he's trying to do at SJ and a bit more of his background and where they think they could go.
So Kaylin, you're currently muted.
Yes.
Yeah. Okay, now you're good. Excellent.
Yeah, I had to find where my mouse button was and everything else. Yeah, we had some slight technical difficulties getting on today, but I think we have them sorted. Can you hear me?
Yes.
Okay, good. So last week, yeah, we had a short conversation with Doug and Siogi, and yes, we covered a lot of the territory that was just covered now with you guys. What we're interested in for right now is looking for some alternatives to doing forward modeling and inversions. And right now we're looking to do, large loop EM, 2D inversions, or, or an alternative to that, and MT, and we're just getting our feet wet now. So we've got some Slack accounts just this week, and Google Hangout. We've tried that out, and we tried it out on Firefox earlier this week, and guess what? It worked. And then we tried to join the meeting today. It says, oh, no, it doesn't work on Firefox, only Chrome. I don't know if you've had that before. Anyway, the first thing we wanted to do was maybe try to do a just some forward modeling again, and maybe with some conductive plates in a half space, and see how that compares with Maxwell, because that's something that Maxwell does very well, apparently. So I've just been playing around with some code this week and experimenting a bit, but that's the extent of it. I guess you guys know Goodney, and he worked for us for a little while, and he was our SimPEG guy, and then he up and left, which was really unfortunate, because now we want to take this to the next step, and he's not around. That's what I have to say right now. I mean, I'm really keen on, making comments about what I find, and, fixing the odd thing here and there, and putting that back right away. So I don't know what the best way to proceed from here is. I mean, I've got like a one-liner bug fix, so I've never done a what do you call it? A pull request in GitHub before, so maybe that would be a good idea to try that out there. It's very minor. When I was going through some of the examples, some of the code was obviously copied from, say, the grav to the mag, or vice versa, because a lot of the comments in there still refer to the magnetometer when it's actually the gravimeter example. Just stuff, adding comments in here and there where I thought it was a bit lacking. Or I could do that in, with a running Google Doc example. Anyway.
Well, if you have fixes to contribute,
Mm-hmm.
we can. Have you used GitHub before, or not much?
I have not. I looked at how it works. I mean, I got the tutorial down, and it seems to be very straightforward.
Well, maybe what we can do is, like, at the end of this meeting, if you're willing to stick around, and if Andrea is willing to stick around, we'll get you both onto the SimPEG organization, and then we'll walk through actually how to do a pull request.
Wow, that would be awesome.
Yeah. So, well, if you've got a bug fix like marked that you're ready to fix, then let's do that actually just like at the end of this call.
Sure.
Okay, excellent. And then for the large loop modeling that you're doing, is it time domain or frequency domain?
Time domain.
Okay. Because I remember talking to Gutney a while back, and I think he was actually using the cylindrical code potentially for doing some 1D or like a coincident plate kind of modeling. Does that ring any bells?
It was a 1D modeling inversion that he was doing. He was using a circular loop with a circular model with a B sensor right in the middle of it.
Okay. Okay, but now you're looking more so for like a square loop and a 3D geology. Is that?
Yeah, yeah, a more generalized. I mean, we're still interested in the 1D case, so I have to go back and look what he did. But you know, we're interested in also moving forward with like a more, general EM survey types.
Excellent. Doggy, did you have a question or wanted to jump in?
No.
Oh, okay, no worries. Doug, anybody at UBC or CSM have comments?
Not really, except that I'm just wondering now, from the point of view of Kaylin actually trying to put together something for doing the forward modeling and the testing. Is that, are you planning to do that all in a Jupyter notebook so that it could be passed on and other people could kind of take a look at it and maybe work with it too? I'm thinking especially as as things are set up in an octree, and then you've actually got a plate in there, just to be able to share that particular example and start to collaborate that way. Is how do you envision moving forth and then still try to interact with others so that we can move together here?
When I usually make examples for myself, they're just simple Python scripts. If it's more useful to do a Jupyter notebook to for playing around, then for other people, because it's really self-contained and easy to use, I can see the benefit of that. That would be no problem either.
Your email, I was at workshop all day.
Okay, I mean that seems to be beneficial. Nicer way of being able to parse the problem out and to interact and see what's going on.
Yeah, I mean, the just to define the problem and to generate the output that we need to do the comparisons with. And that would be the immediate goal anyway for the forward modeling project that we have in mind here.
Well, I guess as a comparison, I'm not sure this is a good idea, Lindsay, but it just crossed my mind. So the cylindrical code with a 1D background, and so if you take a loop and you put a B field receiver at the center, you're going to get virtually the same result as if you had a square loop and normalized by the area of that loop, and you should start to get pretty much the same result from the cylindrical code, in which you have really good accuracy because you've got one fewer dimension. And then when you go to an octree code and you're discretizing things with octree, I mean, it's just a way of generating an example. It gives you something, and then you can use that as a check for your next step of sophistication in the modeling.
Yeah, I completely agree. I think the cylindrical code is a good place to start. It's real time, so you don't have to wait to figure out if there's a bug or that something went wrong.
Yeah, I think that's a kind of really good point. That outside of the I'm not sure what is outside, but other people can contribute, because the SimPEG code is, let's say, EM code, for instance, tested for certain cases. like a certain applications, but like not really tested for a whole bunch of applications. So, I mean, like setting up certain application and testing with some analytics, for instance, that's a really good contribution and make it available to other people. So, I mean, that could be sort of the first pathway that other people can contribute back.
Yeah, because it seems to be set up for retail.
Yeah, so echoing Doug and Soggy there, I think starting with the 3D silk or the 2D silk code, we can put a thin plate in, and that's a really great place to start getting familiar with SimPEG, and then we can start to build complexity and play around with the Octree code once you're sort of more familiar with the API and all of that. Sorry, when I throw around the term API, do people know what I mean by that? Kaylin, does CSM, is that a term that resonates or no? No? Not me, but that's fair. So API is application programming interface. So what that means is it's basically like the layer of code that you as a user are interacting with. So you're not necessarily like reading every single line of code, but you're calling functions. And so the way that we've organized and named those is an API.
Okay. Thank you.
Kaylin, did you have any other questions or thoughts that you wanted to bring up at this point? Like, have you actually used SimPEG before, or you've sort of just interfaced with Udemy?
Goodney was doing all the heavy lifting and all the programming. So this is really my first, I guess, deep dive into SimPEG. So yeah.
Excellent. Well, welcome.
Thank you.
Cool. Doug, did you want to bring up questions or ideas about gravity, or do you want to table that for later? We still have a few minutes, so.
Well, maybe I could just open that up a little bit. The reason that it kind of surfaced was that Vahid, and he could talk a little bit about the problem in a bit, has been doing some gravity, well, he wants to do gravity inversion on a geothermal deposit in Iran. And so he's got the gravity data, and then he was doing a terrain correction using a couple of different programs and getting out different results. And of course, the inversion results are different, and you know, like, what do we believe, what don't we believe? There's an underlying challenge here if the data are not processed as well as they possibly can be. And it's a region with very high topography, and you know, there's different ways of doing it. He was using GeoSci, and then he was also using Ross Groom's codes too. So two different ways of working with things, two different results. And Yagwa, you and Chris and Andy had done that work, which frankly, I think I knew about it at one point, but I completely forgot about it until our conversation yesterday, where you were doing terrain corrections using your quad tree formulation and vertical cylinders. It seems that since it's a problem that's of interest here right now, it's a problem that you guys at CSM are expert on, that it would be really advantageous from a number of perspectives to think about this as you know, a connection project where we develop something within a Python framework within SimPEG that actually does terrain corrections and perhaps does it as well or better than anything else that's out there. So I think I just wanted to kind of throw that out as a possibility for kind of working on things, because now we've got something that involves quad trees and real topography, and if we could do something, it'd be interesting. I'm not sure that there's enough new stuff there to actually write a paper, but when sitting around at lunch today, we're realizing that over Iran, you don't really have great resolution digital terrain data. And right now, Vahid's using basically 250 meter cells. I think we can get 90, according to Dom. But I mean, there's a lot of topography there, and frankly, I'm not sure what the best way of handling that is when you only got a poor terrain model or what we could do. Anyway, there's stuff here. There's scope. It's in the end, it's a tool that if we had readily available would be of interest to people. And so I don't know the code that you have, where you said you distributed it. Do people know about it? Are they using it, or has it gone where?
Well, it's distributed to the sponsors of GeoSci. It's not widely distributed, nor is it open source. At this point, actually, to be frank, we are open to do whatever we can, and that's something that Joe I've been talking about is actually trying to write some of his Fortran codes under Python. And I'll let Joe comment on that shortly. But back to the problem itself. So I believe in Iran, in low latitude area, the mid latitude, there should be 30-meter SRTM data. 90 is kind of really to very low latitude. That's one thing. And another is that with the code we have, Doug, as I mentioned yesterday, we're using a flat-topped prism. I think if we can implement this, we should really go to the next step, make it sloping-topped prism. That's one thing. And other part I want to suggest is that if you have really extreme terrain, and if it's still a possibility, someone really could just go back to those stations, kind of measure using a inclinometer, measure a few data points around those critical stations. And you can use that to supplement the SRTM data. And if someone wants to get a paper out of that, that's doable. And no, I don't think anyone has done combination of the near station measurement with the DEM data in general. There's possibility.
Okay, that's interesting. Is there an analytic solution for the prism with a sloping edge?
Yeah, and so that would be what of all the people, it's Colin Barnett's paper.
Oh yeah.
Yes.
And every polygonal body has a closed form solution.
Yeah. So that's widely available. Yeah. Joe, do you want to comment on the possibility of wrapping a lot of stuff we have here?
So yeah, I can comment a little bit. So it's like for our stuff that we have, it's I've been working on having most of our Fortran code or Fortran and C stuff wrapped into Python. So like our sensitivity matrices and just forward modeling, gravity gradient, all those things to just kind of accelerate them and being able to, build or take advantage of OpenMP parallelism, which you can't really do with Python as easily as you can with C or Scythe, or you can also use it with Cython as well. So most of the things are just basically C and Cython wrappers for compiled codes. My thoughts are that they're currently kind of built around a bare bones in-house meshing, rectilinear mesh thing. And my thought would be to switch that to discretize and instead help maybe provide some faster compiled codes to do some of the potential fields modeling, at least using the discretized meshes. And I have some ideas on how I would go about doing that, but that would be one of my thoughts. Because I have a lot of experience with wrapping Python codes and wrapping Fortran Python codes in a easy, or at least a reproducible way that doesn't necessarily use the f to pi function, because that can break down some of these specialized codes that we have.
Yeah, so within that context, depending on how the group collectively decide to proceed with the train correction, one is go ahead with putting together a native set of SimPEG code. Another I can see possible path forward is just wrap the Fortran code the way Joe has been doing, and make it somewhat part of the SimPEG. That's
my thought would be to, if there's a way that you could possibly provide like a Python native version, and then also provide at the same time a compiled version that would call the same codes. And the way you can write it in such a way that if you import the accelerated version, it would replace those codes within SimPEG. So it wouldn't necessarily do anything like to the end user. They would just be able to natively take advantage of it if they have it installed.
That's a great idea.
Yeah, I think that's a great way to go, Joe.
Great appeal from a whole bunch of perspectives. First of all, just kind of getting a project that CSM and UBC and the rest of us are all kind of interested in, and also it's generic, right? I mean, the things that are done here from the methodology point of view then can get extended to other problems. So I don't know, it's just got the right feel about it. I really quite like this. Let's explore that then, after this conversation, and just try to figure out some kind of a path forward that would benefit everybody.
That sounds good. Are there any? So we're just over the hour now. Are there any last questions, comments, things that people would like to bring up today?
Okay, Caitlin, do you have anything else to offer? At the end of our conversation the other day, you also said, there's a programmer at SJ that we could potentially get to help if there was some problem of kind of mutual interest. Is that still available? And what kind of a project, or do you have anything in mind that might actually be useful at this point, given that you're interacting with Goodney and you can sort of see what he was doing?
I don't know. I guess we'll have to see what kind of resources we can allot to get him involved with this a little bit. He's not a geophysicist or anything like that by any means. So, but he might be able to help out with some programming stuff.
I think that bringing in an extra skill set is often more valuable than augmenting the skill set that you have by one.
I could probably get a better answer for you next time we talk.
Okay, well, it's just something to kind of keep in background. We don't have anything particular at this point, but it's just nice to know who out there within the group has got capabilities, and if there's problems that come up, then sometimes maybe we can just ask that particular person to contribute or some ideas and go forward much more efficiently.
Excellent. Okay, well,
yeah, I agree with that.
Oh, I did.
Oh, I did. Well, where did he come from?
Working all the time.
I couldn't get my computer to work. We've had fiber optic put into the office here, and there's all kinds of issues with it. So
whoa. Well, I'm glad I didn't say anything bad about Sid.
who is interested in getting hooked up to GitHub, Slack, sort of those community pipelines, just stay online. And then otherwise, we will connect again next week. And so we always circulate the notes. We'll try and maybe get a bit better about circulating them a day or two beforehand so people can add things that they want to talk about the following day. So, but it's every Tuesday, and you're always welcome. Cool. All right.
Thanks, Lindsay. Thanks, everyone.
Thanks, everyone.
Hey, thanks, Galen. Thanks, Yago and group. That was great. That was really good.
Thanks, Doug.
Okay. We'll be in touch on a whole bunch of things later.
Sure.
Okay.
All right.
Yeah, so
yeah,
I need to meet up